What if I told you that genius is not something you are born with, but something you can build, piece by changing the way you think? Most people believe that brilliant minds like Einstein or Newton possessed some magical gift, some spark that ordinary people simply do not have. But here is the truth. Genius is not about having a bigger brain or faster neurons. It is about adopting a specific way of looking at the world, a way of asking questions, a way of refusing to accept what everyone else takes for granted. And the best part? You can train yourself to think this way. Let us start with a simple observation. When you watch a child play, what do you see? You see someone who is constantly asking, why? Why is the sky blue? Why does the ball bounce? Why does ice melt? Children are natural scientists. They do not accept the world as it is. They poke at it, test it, break it apart to see how it works. But somewhere along the way, most of us lose that curiosity. We start accepting answers without questioning them. We stop asking why and start memorizing what. And that is the first step toward ordinary thinking. Now, imagine you are holding a cup of hot coffee. You know it will cool down eventually, right? But why? Most people would say, well, heat escapes. But what does that even mean? Where does the heat go? Does it vanish into thin air? If you stop and really think about it, you realize you do not actually understand what is happening. The coffee molecules are jiggling around, vibrating with energy. The air molecules around the cup are also jiggling, but more slowly. When fast-moving coffee molecules bump into slow-moving air molecules, they share their energy. The coffee slows down, the air speeds up, and we call that cooling. Suddenly, cooling is not some abstract thing. It is a dance of molecules, a transfer of motion. That is what real understanding feels like. It is not memorizing that heat escapes. It is seeing the invisible mechanism behind it. Here is the first principle of thinking like a genius. Never accept an explanation until you can see it in your mind. If you cannot visualize what is happening, if you cannot explain it in simple terms without jargon, then you do not truly understand it. Feynman himself once said, "If I cannot reduce something to the level of a freshman lecture, I do not really understand it." This is not about dumbing things down. It is about cutting through the fog of complicated language to find the core truth underneath. Let me give you another example. You have probably heard that light behaves like both a wave and a particle. Sounds mysterious, right? Almost magical. But what does that actually mean? Most people just accept it as a weird quirk of quantum mechanics and move on. But if you want to think like a genius, you cannot do that. You have to stop and wrestle with it. Imagine you are standing by a pond and you toss a pebble into the water. Ripples spread out in circles. Those ripples are waves. Now imagine you throw a handful of sand. Each grain lands in a different spot. Those grains are particles. Waves spread out and interfere with each other. Particles are localized and countable. So how can light be both? Well, when you are not looking at light, when it is traveling through space, it spreads out like a wave. It can bend around corners, interfere with itself, create patterns. But the moment you try to detect it, the moment you measure where it is, it behaves like a particle. It hits a specific spot on a detector. It is as if light exists in a superposition of possibilities until you force it to make a choice. That is strange, yes, but it is not magic. It is nature showing us that our everyday intuition about how things should behave does not always apply at tiny scales. And this brings us to the second principle. Embrace confusion as the starting point of understanding. Most people avoid confusion. They feel uncomfortable when something does not make sense, so they either ignore it or pretend to understand it. But geniuses do the opposite. They run toward confusion. They know that the moment you feel confused, you are standing at the edge of something you do not yet understand. And that is where all the interesting stuff happens. When Feynman encountered something confusing, he would sit with it. He would turn it over in his mind, look at it from different angles, ask himself what would happen if he changed one little thing. He treated confusion like a puzzle, not a problem. Let me show you how this works. Suppose I ask you, why do we see a rainbow after it rains? You might say, well, sunlight gets split into colors when it passes through water droplets. Okay, but why does it split? Why does white light contain all those colors in the first place? And why does a rainbow always appear in the same order? Red, orange, yellow, green, blue, indigo, violet. If you do not know the answers, that is fine. But here is what a genius would do. They would start playing with the idea. They would imagine themselves as a beam of light entering a water droplet. What happens? The light slows down a little because water is denser than air. When it slows down, it bends. That is refraction. But different colors of light bend by different amounts. Red bends less, violet bends more. So when white light enters the droplet, it spreads out into a spectrum. Then it bounces off the back of the droplet and bends again on the way out, spreading even further. And because of the geometry of the droplet and the angle of the sun, those separated colors reach your eye at slightly different angles. That is why you see them as a band of colors in the sky. Suddenly, a rainbow is not just a pretty thing. It is a consequence of geometry, refraction, and the nature of light itself. Here is the third principle. Break everything down into first principles. Do not rely on what other people tell you. Do not memorize formulas or facts. Instead, ask yourself, what are the fundamental truths here? What are the basic building blocks? Then, reconstruct the idea from the ground up. This is how Feynman approached physics. He did not just learn equations, he derived them himself, over and over, until they became second nature. He wanted to know where they came from, why they worked, what assumptions they rested on. And because he understood things at that deep level, he could apply them in ways no one else had thought of. Let me give you a practical way to use this in your own life. Suppose you were trying to learn something new, maybe a concept in mathematics or science or even history. Most people would read a textbook or watch a video and try to absorb the information. But that is passive learning. You are just letting someone else pour knowledge into your head. Instead, try this. After you learn something, close the book. Put away your notes. Now, explain it to yourself out loud as if you were teaching it to someone who knows nothing about the subject. Use your own words. Use analogies. Draw pictures if you need to. And here is the key. Whenever you get stuck, whenever you cannot explain something clearly, that is a gap in your understanding. Go back and fill that gap. Do not move on until you can explain it smoothly. This technique, by the way, is sometimes called the Feynman technique, and it works because it forces you to confront what you do not actually know. Now, let us talk about something that might surprise you. Geniuses are not afraid to look stupid. In fact, they embrace it. Feynman was famous for asking questions that seemed almost childishly simple. He would walk into a lecture full of brilliant physicists and say, "Wait, I do not understand. Can you explain that again?" And people would look at him like he was joking, but he was not. He genuinely wanted to understand, and he knew that if something did not make sense to him, it probably did not make sense to others either. They were just too afraid to admit it. This is the fourth principle. Be willing to admit what you do not know. Most people pretend to understand things because they do not want to look ignorant, but that pretense is a prison. It traps you in shallow knowledge. Geniuses are free because they are honest about their confusion. Here is another thought experiment. Imagine you are an alien visiting Earth for the first time. You see humans doing all kinds of strange things. They stare at glowing rectangles for hours. They exchange pieces of paper and metal for food. They gather in large groups and make loud noises together. If you did not know what money or phones or concerts were, you would be completely baffled. But you would also have an advantage. You would see these things with fresh eyes, without any preconceptions. You would ask the most basic questions. Why do humans value these pieces of paper? What is the purpose of this ritual? And in doing so, you might notice patterns and connections that people who grew up with these things completely miss. That is the power of beginner's mind. It is the ability to look at something familiar as if you are seeing it for the first time. Geniuses cultivate this skill. They deliberately forget what they think they know and approach problems as if everything is new. Let me show you how this works with a classic puzzle. You have probably heard that nothing can travel faster than the speed of light. But why? What is so special about light? Why does the universe have a speed limit at all? Most people accept this as a law of physics and move on. But if you approach it with beginner's mind, you might ask, what would happen if something did go faster than light? Well, according to Einstein's theory of relativity, as you go faster, time slows down for you relative to someone who is standing still. The closer you get to the speed of light, the slower your clock ticks. If you could reach the speed of light, time would stop completely. And if you went faster, time would have to go backward. But that creates all kinds of paradoxes. You could arrive before you left. You could interfere with your own past. The universe does not allow that kind of chaos, so it enforces a speed limit. The speed of light is not just the speed of light. It is the speed of causality, the maximum rate at which cause and effect can propagate through space. Suddenly, this strange rule makes sense. It is not arbitrary. It is a consequence of how time and space are woven together. Here is the fifth principle. Always ask what would happen if things were different. This is the power of counterfactual thinking. Do not just accept the world as it is. Imagine what would change if one thing were different. What if gravity were twice as strong? What if electrons had a different charge? What if the Earth spun faster? By exploring these hypothetical scenarios, you start to see why things are the way they are. You see the hidden constraints, the delicate balances, the reasons behind the rules. Let me give you a concrete example of how powerful this can be. Think about why the sky is blue. You probably know it has something to do with the atmosphere, but why blue specifically? Why not green or red? Here is where counterfactual thinking helps. Imagine sunlight is traveling through space toward Earth. Sunlight looks white, but it is actually a mixture of all colors. Now, when that light hits the atmosphere, it encounters air molecules. These molecules are tiny, much smaller than the wavelength of light. When light hits something that small, it scatters in all directions. But here is the key. Blue light has a shorter wavelength than red light, and shorter wavelengths scatter more easily. So blue light gets scattered all over the sky, bouncing from molecule to molecule, coming at your eyes from every direction. That is why the sky looks blue. Red light, with its longer wavelength, mostly passes straight through. Now ask yourself, what if air molecules were bigger? If they were closer to the wavelength of red light, the sky might look red instead. What if there were no atmosphere at all? Then there would be no scattering, and the sky would be black, just like it is on the moon. By playing with these what-ifs, you start to see that the blue sky is not random. It is a consequence of the size of air molecules, the wavelength of light, and the physics of scattering. Now let us talk about something that holds most people back: the fear of being wrong. In school, we are taught that being wrong is bad. You lose points on tests. You get corrected in front of the class. So we learn to avoid mistakes, to play it safe, to only say things we are sure about. But geniuses know that being wrong is essential. Every mistake is information. It tells you where your model of the world breaks down. It shows you what you need to fix. Feynman loved being wrong because it meant he was about to learn something new. He once said, "I would rather have questions that cannot be answered than answers that cannot be questioned." That is the mindset of someone who values truth over ego. Think about how science actually progresses. It is not a straight line from ignorance to knowledge. It is a messy process of guessing, testing, failing, and revising. Scientists propose hypotheses that turn out to be wrong all the time. But each wrong hypothesis teaches them something. It eliminates a possibility. It points them in a new direction. Edison famously said he did not fail to make a light bulb 10,000 times. He successfully found 10,000 ways that did not work. That is not just a cute saying. It is a profound truth about how discovery happens. You have to be willing to try things that might not work. You have to be willing to look foolish. You have to be willing to say, "I thought this would happen, but it did not, so now I need to rethink my assumptions." Here is the sixth principle. Treat your ideas as experiments, not beliefs. Most people get attached to their ideas. They invest their ego in being right. So when evidence contradicts them, they feel personally attacked and they dig in deeper. But geniuses hold their ideas lightly. They say, "Here is what I think might be true. Let me test it and see what happens. If it works, great. If it does not, even better, because now I know something I did not know before." This attitude transforms learning from a test of your intelligence into an adventure of discovery. Let me tell you about one of Feynman's favorite strategies. He called it working backward. When he encountered a difficult problem, instead of trying to solve it directly, he would ask himself, what would the answer look like if I already had it? What properties would it have? What constraints would it satisfy? Then he would work backward from that imagined solution to figure out how to get there. This might sound strange, but it is incredibly powerful. It is like trying to navigate a maze. If you only look at what is right in front of you, you can wander around forever. But if you can see the exit, even from a distance, you can orient yourself and make progress toward it. Here is how you can use this in your own thinking. Suppose you are trying to understand why planets orbit the sun in ellipses instead of circles. You might start by imagining what it would take for an orbit to be perfectly circular. Well, the planet would need to be moving at exactly the right speed so that the inward pull of gravity is perfectly balanced by the outward pull of its motion. But what if the planet is moving a little too fast or a little too slow? Then the orbit would not be circular anymore. It would stretch out into an ellipse. And in fact, a circle is just a special case of an ellipse, one where the planet happens to be moving at exactly the right speed. By working backward from the solution, you can see why ellipses are the natural shape of orbits and why circles are rare. Now let us talk about one more principle, and this one might be the most important of all. Enjoy the process of not knowing. Most people are uncomfortable with uncertainty. They want answers right away. They want to feel smart and competent. But geniuses have a different relationship with uncertainty. They find it exciting. There is a wonderful moment when you are working on a problem and you have no idea how to solve it. You are completely stuck. Most people hate that feeling, but Feynman loved it. He said that feeling of being stuck, that tension of not knowing, is the best part. It means you are working at the edge of your abilities. It means you are about to grow. And when you finally figure it out, when the pieces click into place and the fog lifts and you see the answer, that feeling of discovery is one of the most joyful experiences a human being can have. Think about the last time you solved a really hard puzzle or figured out something that had been bothering you for days. Remember that rush of excitement? That is not just a nice bonus. That is the reward your brain gives you for learning. Your brain is designed to seek out patterns, to make sense of the world, and when it succeeds, it floods you with dopamine. Geniuses tap into that reward system. They make learning feel like play. They turn every problem into a game, every mystery into an adventure. So how do you train yourself to think this way? Start small. Pick something you think you understand and try to explain it to yourself in the simplest possible terms. If you get stuck, if you realize you do not actually know why something works, celebrate that. You just found a gap. Fill it. Then pick something harder. Challenge yourself to question things you have always taken for granted. Why does ice float? Why do we have seasons? Why does the moon always show us the same face? Do not look up the answers immediately. Spend time thinking about it. Make guesses. Test your guesses. Let yourself be wrong. Then, when you finally learn the real explanation, it will stick because you have already wrestled with the problem. Here is another exercise you can try. Take a concept you learned recently and try to come up with an analogy for it. Do not use the standard analogy everyone uses. Make up your own. This forces you to really understand the underlying mechanism because you have to find the deep similarity between two things that seem completely different on the surface. For example, you might compare the flow of electricity through a wire to the flow of water through a pipe. Voltage is like water pressure. Current is like the amount of water flowing. Resistance is like the narrowness of the pipe. This analogy is not perfect, but it helps you build intuition. And the act of creating the analogy forces you to think about what is essential and what is just surface detail. Here is the beautiful secret. Genius is not about knowing everything. It is about knowing how to figure things out. It is about having the tools to take any problem, no matter how complex, and break it down into pieces you can understand. And those tools are not genetic. They are not handed out at birth. They are skills. They are habits. They are ways of thinking that anyone can learn. You just have to be willing to ask why, to embrace confusion, to admit what you do not know, and to keep pushing until the fog clears and you see the beautiful, simple truth underneath. Every time you do this, you are not just learning a fact, you are rewiring your brain. You are building new neural pathways. You are becoming someone who thinks differently. And over time, those small changes add up. You start to see connections other people miss. You start to ask better questions. You start to solve problems in creative ways. That is what genius looks like from the inside. It is not a flash of inspiration that comes out of nowhere. It is the result of thousands of small acts of curiosity. Thousands of moments where you chose to dig deeper instead of accepting the easy answer. So the next time you encounter something you do not understand, do not shy away from it. Lean into it. Play with it. Turn it over in your mind. Ask yourself what would happen if things were different. Explain it to yourself in simple terms. And when you finally understand it, when you can see it clearly in your mind, savor that moment. because that is the moment you just became a little bit more of a genius.